Welcome to my channel and I'm glad to see you today. First, let's take a look at these data sets. As you can see, there are some observations down the columns where there are blank spaces. This kind of blank spaces in a data set where there are no recorded values is called missing data. It can also be called missing values, but most often in research, they are referred to as missing data. Missing data are common in data sets and they can be present in different patterns, either as missing at random, or missing completely at random, or missing none at random. But whichever pattern the missing data takes, they can have a significant effect on the conclusion that can be drawn from the data analysis, especially if the missing data is beyond a certain percentage threshold of occurrence in the data set. However, in SPSS, results are always produced regardless of whether your dataset has missing values or not. It is therefore your duty to check if there are missing data and identify if the percentage of missing data falls within the permitted range of what you can proceed with. Technically, if the missing data is in a random pattern in your dataset and is statistically less than 5% of the total data, then the missing data can be considered to be harmless to the data analysis and the statistical results will not be biased. In this case, you can choose to continue with the data analysis without fixing the missing data. But if the pattern of the missing data is non-random in your dataset and is statistically more than 5% of the total data, then the missing data can be considered to be harmful to the data analysis and the output result will be biased. So in this case, you must choose to fix the missing data by providing values for the blank spaces before you can continue with the data analysis. But if you failed or refuse to fix the missing data before proceeding to analyze the data, then there is high probability that the result output of your data analysis will be biased because missing data can do the following to your dataset. 1. They can add ambiguity to your data analysis. 2. They can reduce the statistical power of the analysis, which can distort the validity of the results. 3. They can reduce the representativeness of the samples. 4. They can cause bias in the estimation of parameters. And 5. Missing data can lead to invalid conclusion. The choice of how to fix the missing data is all yours, and you must be careful of the choice you make among the methods to fix the missing data so that you don't end up bringing outliers into your dataset that can affect the output of your result, such as introducing bias on the mean. So in this video, I'll be demonstrating the two best ways to fix missing data in SPSS. My name is Titocan and this is Titocan Max Solutions, a YouTube channel for improving the knowledge of how to do things. Now, let's go into SPSS for the demonstration. As you can see, this is the data we saw earlier. The data has already been loaded into SPSS. If you want to learn how to load data into SPSS, please see my video on Introduction to SPSS Software for Beginners, Part 1. Now, before you proceed to fix the missing data in a dataset, the first thing you should do is to check whether the percentage of missing data is below or above the threshold of 5%. To do that, go to the menu bar and click on Analyze. And from the sub-menu, click on Missing Value Analysis to open the Missing Value Analysis dialog box, as you can see. From the box on the left, move the scale variables and the ordinal variables to the quantitative variables box at the top right, and then move the nominal variables to the categorical variables box on the bottom right. But here in the box on the left, I have sample A to sample F as scale variables, and I have gender as the nominal variable. Now, click on sample A, then hold down the Shift key on the keyboard, and then click on sample F to select all the scale variables. Then, click on this transfer arrow key to move them to the quantitative variables box on the top right. Thereafter, click on the gender and then click on this transfer arrow key to move it to the categorical variables box at the bottom right. Because the objective of this video does not include showing the patterns of the missing data, there will be no need to select features that will produce the patterns of the missing data. However, the features can be found in the patterns dialog box and in the descriptives dialog box. Now, leave every default unchanged, and like this, the SPSS system has been programmed to produce the descriptive statistics of each variable, including their missing data information in a univariate statistics table. Now, click OK to produce the univariate statistics result table. As you can see in this table, the descriptive statistics of the data are presented, including the count and percent of the missing data for each variable or sample in this case. In this table, you should concentrate only on the missing data column, which is categorized into count and percent. Here at this table, sample A has 22 numbers of missing data, which accounts for 24.7%. Similarly, sample B has 17 numbers of missing data, making up 19.1%. And just like that, we have 15 missing data at 16.9% for sample C, and 29 missing data constituting 32.6% for sample D, E, and F respectively. While for gender, there are 32 numbers of missing data accounting for 36.0%. This generally means that the percentage occurrence of the missing data in this dataset is above 5%, and therefore is beyond the threshold of peaceful occurrence in the dataset. So in this case, you must have to fix the missing data before you can proceed to perform any data analysis with this dataset. Typically, there are 5 different ways of fixing missing data in a dataset, which includes 1. List-wise deletion, 2. Pairwise deletion, or call it delete cases analysis by analysis, 3. Mean substitution, 4. Regression-based imputation, and 5. Expectation-maximization algorithm. Among these 5 methods, I have, however, considered regression-based imputation and expectation-maximization algorithm as the best methods to fix missing data in nominal variables, ordinal variables, or scale variables, because these 2 methods can fix the missing data without reducing the size of the dataset through deletion of rows observations and without introducing bias on the mean values of the variables by ensuring that the predicted values are not significantly different from what are supposed to be the observed values. Now, let me give you the synopsis of these 2 methods. Regression-based imputation. This is simply the process of using multiple regression models to make estimates for the missing data points. What this method does is to first estimate the regression model in the available data of each variable, and thereafter use the regression weights to predict the missing values for each variable. Expectation-maximization algorithm. This is an approach for performing maximum likelihood estimation in the presence of latent variables. It does this by first estimating the values for the latent variables, then optimizing the model, and repeating these 2 steps until convergence. It consists of an estimation step referred to as E step and a maximization step called M step. And these 2 steps form an iterative process to improve the model fit. Now, let's go back to our data in SPSS and fix the missing data using these 2 best methods. Now, go to the menu bar and click on Analyze. From the submenu, click on Missing Value Analysis to open the dialog box, as you can see. Here in this dialog box, all your variables are in the box on the left. You must move all the variables to the top right box, regardless of whether it is nominal variable, ordinal variable, or scale variable. Now, from the box on the left, click on Gender. Then, hold down the Shift key on the keyboard and then click on Sample F to select all the variables. Then click on this transfer arrow key to move them to the quantitative variables box at the top right. Then check the box for regression and EM, and immediately the buttons for regression and EM become active. Then click on the regression button to open the missing values analysis regression dialog box. In this dialog box, the radio button for residual is already checked by default. Then move down and check the box for Save Complete Data. This action activates an empty column to create a new dataset. Now, give this dataset a name of your choice. Let's call it ROBI. Then, click Continue to close this dialog box. Now, click on the EM button to open the dialog box. And similarly, check the box for Save Complete Data. This action activates an empty column to create a new dataset. Now, give the dataset a name of your choice. Let's call this one EMA. Then click Continue to close this dialog box. Now click OK, and immediately the two results are produced in new tabs. However, the table of results in this output window are the necessary information of the process with which the missing data are generated for the missing point. But don't bother about them. Now, let's open the new tabs one after another to inspect the outcomes. As you can see, all the missing data in the datasets have been provided with values, and under the gender column, the missing data points have been estimated to be 2 and 1 where necessary. However, in the variables view window, the nominal variable gender is labeled as 1 for male and 2 for female. This means in the gender column, 2 is female and 1 is male. And obviously, you can assign them like this. Now, to be sure that there is no significant difference in the dataset between the original dataset with missing values and after the regression-based imputation and the expectation maximization algorithms were used respectively to fix the missing data, I will perform the descriptive statistics and compare the mean values of the variables for each method. Now, let's start with the original dataset with missing values. That is, go to the menu bar and click on Analyze. And from the sub-menu, put your cursor on the descriptive statistics. And from the drop-down options, click on Frequencies to open the Frequencies dialog box, as you can see. Now, from the box on the left, click on Gender. Then hold down the Shift key on the keyboard and then click on Sample F to select all the variables. Then click on this transfer arrow key to move them to the variables box on the right. Now, click on the Statistics button to open the dialog box, as you can see. Under Central Tendency, check the box for Mean. Then click Continue to close this dialog box. And then uncheck the box for Display Frequency Tables. Now, click OK to produce the results for descriptive statistics. As you can see from this table of results, the missing data is given for each variable, and the mean value is also given each. Now, double-click on the table header and copy out the mean value of each variable like this. You can choose to copy them out one by one. Now, open an Excel spreadsheet and paste them. Then, double-click on the mean cell and change the mean to original for easy identification. Now, repeat this same process for ROBI file and EM file respectively. As you can see from these tables of results, the missing data is 0 for all the variables. That means there is no missing data in the dataset anymore, as the regression-based imputation and the expectation maximization algorithm has been used to fix the missing data respectively. Now, double-click on the table header and copy out the mean value of each variable as usual and then paste them in the Excel spreadsheet. Again, double-click on their mean cells and change their means to ROBI and EMA respectively for easy identification. Now, in Excel, highlight the table. Then go to the menu bar and click Insert. Then click on the column bar chart and select the cluster column to produce the bar chart for original, ROBI, and EMA. From the bar chart, the blue bar is the original dataset with missing data. The orange bar is the dataset fixed with regression-based imputation, while the bar in gray color represents the dataset fixed with expectation maximization algorithm. As you can see, there is no significant difference between the original dataset with missing data and the dataset fixed with ROBI or EMA. This means that you should either use regression-based imputation method or expectation maximization algorithm method to fix your missing data, because they are the best methods and they will not bring bias or outliers into your dataset, and will also not make you lose the size of your dataset because you will not be deleting any row or column in your dataset. This is how to fix missing data in a dataset in SPSS using regression-based imputation method and the expectation-maximization algorithm method respectively. And I hope you will be able to replicate the procedure to fix the missing data in your own dataset. But right now, we have come to the end of this video. If you like this video and you would like to see more video contents like this, please kindly give this video a thumbs up, share this video, and subscribe to my YouTube channel to receive notification every time I publish new and useful content. Subscription is free. Thanks for your time and subscription, and I hope to see you again in my next video. Bye.